Before starting an exploration of systems of nonlinear equations, let's go back and take a look at systems of linear equations. With linear equations, there are three different types of solutions. The first is that the two lines meet in a single point, there would be a single solution. The second case is that the two lines are parallel, they never touch each other, and then there are no solutions. And then the third case is where the two lines are actually the same line and they're right on top of each other, in which case an infinite number of points are touching the other line's infinite number of points. Well, for systems of nonlinear equations, you can have one or more equation that is nonlinear. So in this case, we have y equals x here, which is a linear equation, and we have the parabolic function x squared plus 3, which is just x squared shifted up 3 points. And we notice that this line doesn't touch this parabola at any point. So in this case, there are no solutions. In the second case, we have the second order equation is x squared minus 4, and we have our line y equals x goes through it and touches the parabola at two separate points. So this has two solutions. And in this case, we have a line that is just y equals minus 2 linear equation, and we have a second order equation which is touching that in a single point. So this is a tangent line to the parabola, and this has one solution. Now, in a situation where we have two nonlinear graphs, in this case, two second order equations, it's possible that the two of them never touch anywhere. So in this case, there are no solutions. Here we have two nonlinear functions that cross and touch at 2 points, so there are two solutions. And here we have two parabolas, one is a reflection of the other, and they only touch each other in a single point, meaning that there's only one solution. Here we have two equations. The first equation is a second order equation. This is nonlinear. Equation 2 is a linear equation. And there are several ways of solving nonlinear equations. And if you recall from solving systems of linear equations, the first one was to graph the solution. Here I'm using Desmos for the graphing calculator, and I've entered the equations of the two lines. So the first one, nonlinear second order equation, is a parabolic function. And the second equation, which is linear, y equals minus 2x minus 1 is on here. And I want to look at the point where the two are touching each other, and I get 0 comma minus 1. So I've recorded that there was one solution on the graph, and it was 0 comma minus 1. The next method for solving a system of nonlinear equations is with substitution. And here I have the second order equation. It's much easier for me to substitute this inside this one. So since I have y equals minus 2x minus 1, I can substitute that for y over here. Once I have minus 2x minus 1 substituted in for the y, I only have x's, and now I'm going to solve the equation for x. So I'm going to add 2x to both sides. And I'm going to also add 1 to both sides. And when I do this, I get 0 on the left equals x squared. And these are a 0 pair. So I have x squared equals 0. When I take the square root of both sides, I get x equals 0. And that is confirmed from our graphing solution. Now I'm going to take the x equals 0 and plug it into this equation over here. Once I have the 0 substituted for x, minus 2 times 0 is 0, so y equals minus 1. And that confirms our one solution that we got from graphing. And if you recall from systems of linear equations, the third type of solution that we can find is through elimination. So what I would do, in this case, I would subtract this one from this one. And the reason why, this is minus 2x minus 1, this is minus 2x minus 1. So subtracting a negative is the same as adding it. So I'll write over here, since I'm going to subtract y equals, and then minus 2x minus 1. So when I do y minus y, I get 0. I bring down the x squared. And then when I have minus 2x minus minus 2x, that's the same as adding 2x. So minus 2x plus 2x is 0. And then 1 minus minus 1 is 1 plus 1. That's again 0. And then we're at the point where we take the square root of both sides. And that tells us that x equals 0, which confirms our one solution here. And then again, since I now know that x is 0, I can find this value over here is the same as what we did before. So substituting in minus 2 times 0 is 0, so y is minus 1. The next type of system of nonlinear equations is when we have two second-order equations here. And the first of the two solutions would be to solve it by graphing it. Here I've entered the equations for the two parabolic functions. One opens up, positive x squared, and one opens down, negative x squared. And I notice that these two actually meet at these 2 points here. There are two solutions. So the first solution is minus 1, 2. And the second solution is 2 minus 1. So I've written the two solutions over here, and then we're going to move on to the next method of solving, and that would be with substitution. So since I have y equals minus x squared plus 3 here, I'll substitute this y with the minus x squared plus 3. Now, by moving everything that's on the left over to the right, I'm going to be able to set this equal to 0. So I'm going to add x squared to both sides. And then I'll subtract 3 from both sides. Once I get to this point and I have this equation set equal to 0, I can now factor this. And there's two ways to do that. One is called the ACB method, and the other is to use the quadratic equation. I'll link videos at the end of this one on how to do both of those two skills, but I'm going to review how to do the ACB method right now. So ACB means A times C and B. And what this says is that the coefficients of the first, second, and third term, this is the A term, B is minus 2, and C is minus 4. So A times C is positive 2 times minus 4 is minus 8. So I want two numbers that would multiply to minus 8, but add up to what B is. And B here is minus 2. So two numbers that multiply to 8 would be minus 4 times 2. And if I added minus 4 plus 2, I would get minus 2. So now this down here, I can break this into two pieces. So I'm going to bring down the 2x squared, and I'll bring down the minus 4. And now what I'm doing is I'm taking this minus 2x and breaking it into minus 4x and plus 2x. Well, the minus 4x looks like it would work really well factoring with this piece. And then over here, I can put the plus 2. So this one would be plus 2x. Now, what I do is I'm going to factor these two and factor these two. And what I can pull out of both of these is a 2x. And when I do that, I would get an x plus 1 inside. And then what I can pull out over here is a minus 4. And what would stay inside should be the same as this, which is x plus 1. You can double check it by simply distributing. So 2x times x is 2x squared. And 2x times 1 is 2x. Minus 4 times x is minus 4x. And minus 4 times positive 1 is minus 4. Now what I do is these here can be separated, and I get two equations. So I have x plus 1 equals 0. And when I solve this one, I subtract 1 from both sides. And then I get x equals minus 1. Well, that's the same as what I have over here, x is minus 1. So I'll write that down here, x equals minus 1 for one solution. And for the other, I'm going to take the 2x minus 4. So when I do 2x minus 4 equals 0, I then get 2x equals 4, and then x equals 2. So the second solution, I'll put it up here, x equals 2. So x equals 2 and x equals -1. Now we're not done. I need to take these x's and plug them into, we use this one, it's a little simpler, and then see what our y solutions are. So we'll do the x equals 2, 1. We should get a -1 for y. So I'm going to take x equals 2 and substitute it into here. So now that the substitution is done, I have y equals, looks like an x, y equals minus, and 2 squared is 4, plus 3. So -4 plus 3 is -1. So when I substitute it in a 2, I get a -1. Now we'll try the same thing, substituting -1 for x. So this time I have y equals, I bring down the minus, -1 squared is just a 1, and then I got plus 3, and then -1 plus 3, y equals 2. So when x is -1, y equals 2. And our last solution will be elimination. So I'm going to subtract these. And what I'm going to do is when I subtract, I'll change the signs as necessary here. So I have y minus y is 0. Then I have x squared minus x squared is 2x squared. Then I bring down the minus 2x. And then -1 minus 3 is -4. And if you notice, this is the exact same thing that we had before. So you would factor this either using the quadratic equation or you would factor it using the ACB method. But I've just done it already, so we know that that solution is going to work.